Do math and physics always agree? I hope so, but does that mean that they're just the same thing? To find out, we will plot the height of this projectile versus time, not distance, time. The constant horizontal velocity means we could find the range, but this is the time as it goes up and then comes down. Our first challenge will be to find its maximum height with these familiar equations and an acceleration of negative g. Method 1. Let's use the fact that the vertical velocity is 0 at the max height to find the time, and then plug that time in here. Problem solved. Method 2. Use the third equation and get an answer in just one step. The same answer. That's physics. This is from a math textbook with quadratics and parabolas and the vertex form. Note the difference. We found a difference. Different h's. This h is the vertex. A, B, C, the vertex. So it's the same thing. And oh, hey, look, that's the time. I recognize that. So thank you, math, for reminding us about vertices and for showing us how changing the initial velocity will affect the projectile's max height, and also when it lands. Let's find time, the total hang time, with the quadratic equation. Kinda gross. These would be cleaner if h was 0. The vertex form adds confirmation. But can physics do that? Yes, with time going up and then time coming down. That's what physics is good for. Physical meaning for our equations here. Another method, and this time we focus on final velocity, aka the slope of the parabola. But switching back to math, and this quadratic, this projectile, well, how would you solve it? My first thought would be to try to factor it. Let's check the answer. We recognize this. Symmetry, plus and minus. That was this. What about that? Change, 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 or no change at all. And all this led me to a suggestion for a way to factor any quadratic equation. I thought this was really neat, and I showed it to a math teacher who was a little bit less impressed. They said it was just another form of the quadratic equation, which I guess it is, but that's what physics can do for math. Now let's see if math can return the favor. If math can show physics something about their parabolas. They are, of course, conic sections with an eccentricity of 1. Ellipses and hyperbolas come in a range of different eccentricities, but all parabolas have the same eccentricity and therefore the same shape. Really? All these things have the same shape? Strange, but it is true. All you need to do is zoom in and zoom out to see what I mean. My math friend told me this should be called a dilation, but I'll tell you what I think it should be called. I think it should be called pretty interesting. And it's also convincing. It convinced me that physics has something to learn from math and vice versa.